To mount this on the milling machine, I've got to get onto ideally a machine surface. The tyres obviously sticking down below the casting there. There's a machine surface there where the brake disc goes, and that's the ideal to get onto. I could put some parallels down or something like that, but I've got some little spacers here that were from something from years ago, and I've got a box full of these, and I've had a little measure with the micrometer at pairs of them to give them the height, and I've got 3 pairs there that are within sort of less than half a thou of each other. So what I'm going to do is I'm going to sit them on there. They clear the little step there quite nicely. I'm going to sit 2 of them on, stacked like that, and put a 6mm bolt, countersunk bolt in there. And put 3 pair of these on. Being 3, it's the principle of the milking stool, that it'll always sit flat, sit nicely on a machine surface. Get an Allen key in a moment. Sorry, that one key's there. Just stick them down. I've countersunk one side of them so that the countersink of the bolt is below the surface. Oops, wrong way around. And to only countersunk 3 of them. That way. Make sure there's nothing on this surface there. And there we go, that gives us, that's clear now of the tyre. I seem to allow that rule, so we're a few millimetres off the edge of the tyre. So now when I put that side down towards the milling machine table, I know we're sitting on that as a reference, and I can then machine that side quite happily. As I said before, I'll dial into that inner surface, and then for this side there's a machine surface there. It's been painted, but it's definitely machined. I should have. Big enough. Yeah, I've got a couple of reasonable sized parallels we can put on that side for doing from the other way, machining from the other way. So I'll get set up on the milling table next. I've got the wheel set up here on the milling machine, as you can see. Quite awkward to hold down. I've got a couple of studs there holding the clamp. One's acting sort of as a long jack, machinist jack. There's 2 of them on each side. The wheels fitted with some spacer washers to hold the tyre away from the bed, away from the table, and I've got the centering indicator set up in the spindle there, so I'll just start it up and see where we are. I've got it approximately in the right place to start with. So now if I move, I'm just moving the X axis across, and it's starting to reduce the swing of the needle. If I move the needle more towards the camera there, see what's going on. That's starting as the X-axis is coming across. It's getting less and less. What the units are isn't really important. It's just the minimum movement of the needle you're searching for. That's gone a little bit too far, so going back that way again. Now I'll do the Y-axis the same. And that's starting to increase, so I'm going past that point. There we go. And that's kind of less than a division there. That's back on the X-axis, that's increased it again. The other way has increased it. It's kind of half a division barely there. That knocking is just me tapping the hand wheel around. Yeah, half a division. There's also flick as well, so it's probably not quite a true surface. Now I'm at that point, I'm close. I'm also going to put a dial test indicator in and just double check it, because I'm not 100% trusting of these coaxial indicators. So there we're set up with the dial test indicator. Now as you can see, I've not moved the table at all. You can see, move that around there. Apologies for picking the camera up on the tripod. 0 there. 14 thou there. That's there, just past 0 there. So it's not quite right. Yeah, it's quite a bit off. That's from the centering indicator to a dial test indicator in the spindle. So question which one you trust. I'll just set this up a little bit better off camera and I'll be back to you. After another sort of 10 minutes or so of playing around with the settings here using the dial testing indicator, we've got, I mean, you get a little bit of movement just as you're moving the dial test indicator in the spindle. If I push the spindle I can get wag. So we're 0 there. Move it round to there. We're 0 there. And round to there. And we're 0 at that quadrant. And then round the other way. And we're 0 close to it there as well. Each division 0.01 millimeters, so that's less than half a thou. So at that I'll put the boring head in and take the first initial cut. What we're aiming for here, we've got to take a couple of millimeters out of this bore to suit a different size bearing. We're putting a 60/22 mil bearing, which is a 44 mil OD and a 22 mil bore, 12 mil deep into this side and into the other side. So we'll get the boring head in and get started. For this job I've got some new boring bar tools here. These take the type that take the indexable inserts. They come with inserts for steel, stainless steel. I've got some, again, I think I've mentioned these before, Corloy AK inserts. These are TCGT 110204 AKs, and they're for aluminium turning. There. So we'll put one of those in. Get in the box. So, and these are these have got a nice sharp edge to them, polished, and I think they're positive rake off the top of my head, so should give a better surface finish. So get that in there and get it popped in the boring head. I've just done one little test pass there, and it's cutting beautiful, and it's absolutely even all the way round. So the setting it up with the dial test indicator rather than just trusting to the coax indicator was definitely the way to go. That is absolutely spot on, all sides. It's less than half a thousand, you can't even feel the step, but looking round at it, it's completely even all the way round. Yeah. Okay, I'll go to the bottom of this with this cut, and then do a measurement. Pour a little bit of WD-40 type lubricant in there, just to stop any aluminium build up or help reduce it on the tool tip. And as I get to the bottom there, I'll set the depth stop at that. I actually need to measure how deep I'm going there. It's just started to touch the bottom of the seat. This. That's it. Around about 11 and a half. I need to go a little bit deeper on this. I'll just do a little bit of measuring and checking, then I'll come back to you. Right. I've measured inside the bore and measured the depth. The depth's okay there at 12 millimeters. The bore's, after that couple of light skims, is sitting at 40.22 millimeters, where aiming for a 44mm bearing, so again a couple of thou under there, so sort of 0.02mm less to give us an interference fit on it. So I'll put a little bit more cut on the boring head and we'll take another light skim. And this will lock the boring head up every time I do a cut. Get in. I'll take around another 20 thou off. There's 1 thou per division, so 10 thou travel there. And we'll go again. I suppose really I could have used the automatic boring head for this, except that it takes a different sized tool bit. So we'll get there with this one. I think I'm going to have to replace that that grub screw in there. It seems to get a little bit chewed up. I will come back when I've got a little bit further along. I've took a few more cuts and I've had a little recalculate. My boring bar's in thousandths on its cut, so I've converted my target measurement to inches. So I'm aiming for, let's have a look at my caliper here, 43.92mm to give me a 0.08mm interference fit, which is around about 2 thou. Converting that to inches, decimal inches, that gives me 1.729 is my target for this bore. I've just done a bore measurement. I'm currently at 1.711, so we'll take a little bit more of a cut and see where we go. This is proving quite awkward to actually measure in this space so close to the to the boring head. I should have given myself a little bit more room to work in, so I could hold the bore gauge vertically. But I wanted to be as close and as rigid as possible. I could drop the table down, but I know that I get some variation I'd get some variation when I did that. So at the moment I'm going to try and measure in position here. And it's also not helped by being a shallow bore. I'm trying to keep the bore gauge square and bring it up square as I lift it. What have we got there? 1.245, 1.29 I'm aiming for. 4, 5, so 4, 5, 5. Another 4.5 there to go. And I'll take the little cuts. I'll sneak up on it just to allow for in case there's any deflection or springing in the cut. Well, I'll go a couple more divisions. So one division is 1 thou increase in cut on this boring head. Yep, I really must replace that grub screw. The measurement, I've took another skim again, a springing cut, and I've been getting sort of 1.7284. That was the last sort of measurement, 1.7284. And I've just done another cut. I'm getting 0.7295, 0.7296. So I think I'm about the 1.729 and a half region there. Just another reading. Oh, that 1.729, 1.7289. Sorry, 95. Yeah, I think I'm there. I'm happy at that. Right, I'll take the wheel out and set it up the other way. And there's a little shot of that side bored out. That's come out nice, that has. A nice finish. Them boring bars for the boring head were from Kronos Engineering. They were them Corloy aluminium turning inserts in. That's I'm really pleased with that.